Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to talk about the relationship between rate and rate order. So to understand this, we have to understand a little bit of vocabulary when it comes to kinetics, because there's a lot of vocabulary words that sound really, really similar. Okay, so let's pretend that we have this equation of A reacting to form B. So these are the reactants, these are the products, excuse me. So some of the words that are kind of similar is we have something called the rate law, which is this whole equation. Okay, now this rate is no longer an average rate. This rate is what we would call an instantaneous rate, and it's dependent on the concentration here. Okay, if this exponent is going to be something other than zero. Okay, now so we got this called the rate law. This is called the instantaneous rate. K is going to be called the rate constant. A is in brackets, so that means it's the molarity of A. And then the exponent here is called the rate order. So as you can see, we got a lot of vocabulary words in here that's on the board that have the word rate. We got rate order, we got rate constant, we got instantaneous rate or rate, and all of that makes up the rate law. So we got to be very, very careful when we're reading a prompt. What are they asking for? Are they asking for the rate law, the whole equation? Are they asking for the instantaneous rate or the rate constant or the rate order? So be very careful when you're reading your problems when it comes to kinetics, because a lot of the vocabulary words have that word rate in there. Now, in this video, we are going to be specifically talking about how the rate order and the instantaneous rate are related to each other. Okay, so we got some things to talk about trying to kind of almost like determining the rate order from the rate or figuring out the rate from the rate order. We need to understand this relationship between the instantaneous rate and the rate order to be effective in this unit of kinetics. And this is actually the starting point of all of that understanding. So this is definitely where you should start your journey when trying to understand kinetics in chemistry. So let's go ahead and talk about maybe this chart over here. Okay, what happens if we double A? Okay, and the rate order is 0 or 1 or 2, because rate order of 0, 1, or 2 are the most common rate orders in chemistry. In fact, I bet this makes up maybe like 95%, if not more, of the chemical reactions that actually take place, in the world. Okay, especially when we're talking first year chemistry, like first year college chemistry, or an AP class in college, or an honors, AP class in high school, or an honors class in high school. Typically, we're going to stay within this realm. Even that first year in college, they tend to stay in this realm. So that's kind of where our focus is going to be today. So let's talk about this. Let's say we had this equation, okay? I'm going to just rewrite the rate law, okay? So this rate is going to be equal to the rate constant, and let's say that rate constant has a value of 1, and it's going to be times a to the x, okay? And what I'm going to do is I'm going to plug in a as just a random number. I'm going to say something like 5, okay? And if x is 0, the rate order, remember rate order is going to be that exponent, okay? If it's a 0, well, 5 to the 0 is 1 times 1. Well, this would give me a rate of 1 molarity per second. Well, what would happen if I doubled the amount of A? Now, remember, rate constant, that's always going to stay the same. So doubling the concentration would take us from 5 to 10. But if the rate order is 0, what does that do to my overall rate? So I'm just trying to get you to connect how this affects this, okay? So 10 to the 0 would be 1, okay? Times 1 would still give me 1. So it doesn't matter if I double or triple or quadruple. Any number to the 0 is going to be 1. So whenever something is a rate order of 0, it's not going to change the overall rate. I'm still at 1 molarity per second. So when the rate order is 0, okay, the rate of the reaction is going to stay the same. It's not going to change. It's going to be constant. So really the only thing that determines the rate is going to be the rate constant, okay? Well, let's change this, okay? Let's pretend the rate order was 1, okay? Well, if I change the rate order, the exponent to 1, that's going to affect the rates. So I'm going to erase the rates here, okay? Let's pretend the rate order or the exponent is a 1. Well, if this is a rate order of 1, okay, 5 to the first power is 5 times 1 would give me 5 molarity per second. And 10 to the first power would give me 10 molarity per second. So if I double the concentration, so if A doubles, okay, and the rate order are 1s, okay, what happens to the rate? Well, if you double the concentration, it looks like you double the rate, okay? And this is how we're going to figure out kind of like the exponents, because what we're going to do is we're going to be given chemical reactions, okay? And we're going to say, hey, is A doubling? And if so, what is the rate order going to be? So now let's wrap this up, okay? And say, what if the rate order is 2? Okay, so I'm changing the exponent to 2 because I'm saying, hey, what if the rate order is 2? Okay, so this part right here, we're going to double A, and the rate order is 2. So 5 to the second power is going to give us 25 molarity per second. 10 to the second power is going to give us 100 molarity per second. So what kind of factor is that? Okay, 25 to 100, that looks like an increase of a factor of 4, or a quadrupling. So if A doubles and the rate order is 2, okay, you'd expect that your reaction rate would be 4 times faster if you double the concentration when the rate order is 2, okay? So like I said, okay, we're going to kind of use this information kind of like qualitatively in our next video series where we're comparing reaction rates, okay, and what happens when you double the concentration. If you double the concentration and the rate order is 0, nothing's going to happen to the reaction rate, okay? But if the reaction order is 1, when you double your reactant, the reaction rate is going to work twice as fast, okay? Of course, if the rate order is 2, the reaction rate will quadruple if your rate order is going to be 2, okay? Now, just to bring this home, okay, what I'd like to do is I'd like to do another situation just to make sure you understand this completely. I'm going to change one word up here. I'm going to change that double to triple to make sure that you understand kind of the relationship between the rate order and the rate. So go ahead and pause this video, okay, and try to figure out how would the reaction rate change if it's 0 order, first order, or second order if I tripled the amount of A. And then when you come back, I'll have that data table filled out and we'll check your answers, okay? So if you've unpaused the video and you've already worked this out, okay, once again, what we're saying here is if we're tripling the concentration. So if I started at 5, okay, a triple would be 15, okay? And what we're going to work through is 0 order, first order, and second order to figure out how the change in the rate is going to be. If these are zeros, okay, if the rate order is 0, I'm going to get 1 for here and here, molarity per second, because anything to the 0 is 1, okay? Times my rate constant of 1, I can see that the rate is not changing. So this still stays the same. However, if I change this to 1s, how does that affect my reaction rate? Well, this is going to be 5, okay, and this is going to be 15 molarity per second, if you will, okay? So if I tripled the concentration, my rate gets tripled when the rate order is 1. Okay, so hopefully those two were pretty easy. The third one, we got to kind of watch out for. Let's do the third one, okay? That's when it's a rate order of 2. So let's go ahead and erase my rates and change the exponent from a 1 to a 2. What happens here when we have a rate order of 2 and you've tripled the concentration? Well, 5 squared is going to give me 25 molarity per second. And 15 squared, I'll probably have to get into my calculator and do 15 squared, but I've already done that. Comes out to 225 molarity per second. And now we're going to try to figure out what type of factor that is. Okay, so 225 divided by 25 tells me that that's going to be a factor of 9. Okay, so this is going to increase by a factor of 9 if the rate order is 2 and you triple your concentration. Now, I probably could have used some easier numbers other than 5 and 15 for this. Okay, so just to make sure I have this completely understood, what if I started at 1? A tripling would be this, right? So this number would come out to 1 molarity per second. Of course, if you triple it, remember, if it's a rate order of 2, that's going to be a factor of 9 because 3 squared is going to give you 9. So I hope this video helped you understand the first step in understanding kinetics, and that is the relationship between rate and rate order. When you double or triple the concentration, different things happen to the reaction rate based on the rate order. And if you found this information helpful, please give it a like and subscribe. Adding that comment really pushes this content out to other students that are interested in learning chemistry.